All right, next up we'll look at hypothesis testing. The first type of hypothesis test that we looked at was for one proportion. If you're running a hypothesis test for one proportion, you have the same three conditions. So you need to make sure that you have a random sample, your sample size is less than 10% of the population, and you have at least 10 successes and failures. When you're checking for those 10 successes and failures, make sure that you're using NP and NQ. I don't want to be using P hat and Q hat if I'm given P and Q. So with all of our hypothesis testing, we use phantoms. Our hypotheses for one proportion hypothesis test would just say that our p-value is equal to whatever that proportion is. This should be like an actual percentage here. They should tell you what p is equal to. And then alternatively, we can try and show that p is greater than, less than, or not equal to that percentage. Two formulas that we need to know. The mean or the expected value of p hat should just be whatever we had for the population, so just p. And then for standard deviation, we should be using our little formula here. It says the square root of pq over n. Okay, always make sure that you're stating the significance level if it's not given to you. We are trained to do this with every single one. Remember that we say since whatever our p-value is less than 0.05, that right there, that 0.05 is your significance level. So watch out, sometimes these questions will say test a hypothesis at the 10% level, so that would change this 0.05 here to 10%. Remember that if your p-value is smaller than the significance level, we reject. P-value is small, we reject the null. If your p-value is larger than the significance level, we fail to reject. And we can always run these hypothesis tests on our calculator for multiple choice questions and to check our work on free response. So let's go ahead and look at an example here. It says a large city's Department of Motor Vehicles claimed that 80% of candidates pass a driving test, but a newspaper reporter's survey of 90 randomly selected local teens who had taken the test found only 61 who passed. Does this suggest that the passing rate is lower than the DMV reported? Now this wording here that's saying, does this suggest, that's telling me that I should do a hypothesis test and run phantoms. So we're going to go ahead and start with P. P is what happens in the population. It's listing my parameter. In the population in this problem, they're telling me that 80% of candidates pass the driving test. So I'm going to say 80% pass test. H in phantoms is for our hypotheses. We should always have two of them, the null hypothesis and the alternative. My null hypothesis above here says that P should be equal to whatever we said in the population or the parameter. So I'm assuming that this p-value is 0.8 or 0.80, that 80%. I am going to try and show that the passing rate is lower than reported, so I'm going to try and show that it's less than 80%. The A in phantom stands for our assumptions and conditions, so I'm checking the three conditions we have listed above. The first is that I need to make sure this is random. It says that it's randomly selected teens, so I am good there. Next, I'm checking for a sample size less than 10% of the population. Looks like we surveyed 90 local teens. I'm thinking that 90 is definitely less than 10% of all teens. The last one here, I'm checking for those 10 successes and failures. So I'm going to take my sample size, the 90, multiply by the p-value, so 0.8. And I'll also do times 0.2, which is 1 minus. So we have 72 and 18, definitely greater than 10. So all of my conditions are met. The N in Phantom stands for naming the test. This was a test about proportions, so it gave me an percentage here, and there's only one group, so this is what we call a one-prop z-test. Z because I'm working with proportions. Z-scores always go with those proportions. Okay, T stands for that test statistic, so this is what happened in your population, in your sample. In our sample, we tested 90 teens, and only 61 of them passed. So my p hat would be those 61 out of 90. So 61 out of 90 gives me roughly 68%. Okay, next in Phantoms I have O, which is where I obtain my p-value. With O, I should be making a model, so I'm going to find my expected value of p hat and the standard deviation of p hat. The expected value should match your population, so this should just be my 80%. Standard deviation, I'm going to use this formula up here, so I'm going to take the square root of 0.8 times 0.2 over my sample size of 90. So 0422. So building my model here, I have an average at 0.8, standard deviation 0422. I'm going to drop down my test statistic, which is my p hat, so that's at 68%, so it's going to be somewhere over here on the left. I'm looking for p is less than that, so I'm going to shade to the left. I'm then going to convert this to a z-score. So 0.68 minus the 0.8 dividing by standard deviation. Gives me a z-score of negative 2.84. From there, I can go ahead and use my normal CDF. Again, I'm using normal CDF, not TCDF, since I'm using z-scores. So on my normal CDF, I should have a lower bound of negative, something large and to the left. Upper bound is going to be my z-score, that's where I'm stopping, so the negative 2.84. The mean and standard deviation can stay the same. So this gives me 0.0023. This value right here is our p-value. Okay, next up in M, I'm making a conclusion. So since the 0.0023 is less than 0.05, we reject H naught. P-value is small, so we reject the null. If we are rejecting, this means that we have evidence to suggest we rejected that null hypothesis. So we don't think this null hypothesis is true, meaning we think the alternative is likely. So I'm going to say we have evidence to suggest that the passing rate is lower than the DMV expected or reported. Okay, we can check this by running our one prop z-test on our calculator. If you didn't remember that calculator buttons, I would write it down up here. So this should be called a one prop z-test. So in my calculator, I'm going to go to stat tests. I'm looking for a one prop z-test. I'm going to type in P naught, so that's the p-value you had in your H naught, so 0.8. X was your number of successes, so that was 61 out of 90. My my alternative hypothesis was less than. I'm going to calculate. And it gives me my z-score slightly off there, but relatively close. So we are good to go. Okay, the only other thing that we talked about typically with these one proportion confidence intervals were our types of errors. I would make sure you know the difference between a type 1 and a type 2 error. So a type 1 error occurs when the null hypothesis is in fact true, but we have accidentally rejected it, so we made a mistake there. A type 2 error is when the null hypothesis is false, but we have, quote, accepted it, or what we usually say right here is fail to reject. Okay, so let's quickly go through a type 1 and a type 2 error for this problem that we just did. So a type 1 error would mean that the null hypothesis is actually true. So my null hypothesis was that the passing rate is 80%. So I would start with saying the passing rate is actually 80%, but we are going to reject the hypothesis, so we say that it's lower. So with a type 1 error in this case, the DMV would be accurate in their results, saying that 80% passed, but we're going to come out and say, no, I ran a test and they are false. It's actually lower, which would be wrong. Okay, a type 2 error would be the opposite. So a type 2 error, the null hypothesis is actually false. So my null hypothesis would not be true, so this would mean that the passing rate is not 80%. But we are going to claim that it is. So with a type 2 error, the DMV would be wrong, right? They would say it's actually not 80%, it's less than 80%, but we would say, nope, based on our test, we think that the DMV is correct. Oftentimes on the AP exam, what they'll do is have you run a hypothesis test like we did right here, and then they would ask you to describe a type 1 and a type 2 error as we just did below. Type 1 and type 2 errors you could often see on the multiple choice part of the test as well.